in Mechanical Engineering from IIT Delhi. Dr. Sanjeev Jain worked in industry for a few years before joining IIT faculty in 1996. He was a visiting faculty in Mechanical Engineering department at the University of Auckland, New Zealand in 2005-2006. Currently, he is professor of Mechanical Engineering at Indian Institute of Technology, Delhi. The area of research interested of Dr. Sanjeev Jain is fundamental and applied research in the area of solar cooling and poly generation, enhanced heat transfer, natural refrigerant, building energy efficiency, microscale heat transfer, mind and cognition. Dr. Sanjeev has invited as a keynote speaker at various national and international universities or in institute. Dr. Sanjeev Jain has published around 24 research papers at international journal and presented around 16 international papers in international conferences at abroad and presented around 27 international papers in conferences in India. Dr. Sanjeev Jain has also worked at different sponsor projects, also worked as a co-principal investigator. Under the guidance of Dr. Sanjeev Jain, total 9 PhD candidate awarded till date. And currently, Sir is guiding 7 PhD candidates. Sir has also guided around 36 MTech candidates. So, this is a very short introduction about Dr. Sanjeev Jain. I welcome Dr. Sanjeev Jain for this FDP. And now I request Dr. Sanjeev Jain sir to take over the session. Thank you all, and thank you so much, sir.
Thank you, Dr. Vijay, for the kind introduction. And welcome to all the participants of the Faculty Development Program. I am happy to be with you this morning. And I thank Dr. Vijay for giving me this opportunity to speak to you in an area of my interest, which is related to sustainable energy systems. So in this talk, I would be presenting an overview of the issues and the concerns which are there in refrigeration and air conditioning systems from the perspective of sustainability. In this presentation, I would start with taking few applications of these systems. I would talk a little bit about thermal comfort, the key technology drivers for the development of these systems, and I would be presenting a case study from our own institute, IIT Delhi, where we have a new data center installed about 3 years back. Then I will go over to the basic concept of sustainability. What is the current sustainability paradigm? What are the issues and how are people looking at it? The natural cycles and the need for human beings to align themselves with the natural cycles. And again, I will take up a case of built environment where refrigeration and air conditioning plays a very important role. I would talk about the current understanding and the philosophy in the built environment, which is basically providing the habitat for all. Then I would be summarizing my presentation by talking about sustainability, whether it is a dream or can it become a reality through our own efforts. So as all of you already know, refrigeration is the process where you bring down the temperature of a product or of the environment to a level which is lower than the ambient or the surroundings. And one of the largest applications of refrigeration is, of course, air conditioning. In the case of air conditioning, we are basically talking of treating the air primarily to control its temperature, humidity, quality or cleanliness and proper distribution, so as to provide the right environment for the application or for the comfort of people who may be present there. So there are some commonalities between refrigeration and air conditioning, but these also have their own niche applications as shown in this slide. So if you are talking of humidification and heating, that could be part of air conditioning. And if you are talking of industrial refrigeration, especially cold stores and cold chains, then that comes primarily under refrigeration. This is the traditional way of classifying and differentiating between refrigeration and air conditioning. Now coming to air conditioning, which will be quite a bit of focus in my presentation. So we know that the term which is used by industry is HVAC, which is the acronym for heating, ventilating and air conditioning. And as I mentioned here, we are trying to control the temperature, humidity, air distribution and cleanliness of air, which is also called indoor air quality, which is a highly technical term with lot of interest in the current research. And therefore we talk of having healthy buildings where human beings are safe and remain healthy, even if they stay there for long periods. So some of the common applications of RAC systems are mentioned on this slide. The first one, as I mentioned, is HVAC, which is primarily for thermal comfort of human beings in various applications, including residential, commercial or office applications, industrial applications, even in vehicles. The next major application which could be of interest is cold chain, which could be for the fresh agricultural produce or frozen food, or even it could be for important commodities like vaccines and pharmaceutical drugs. The third major application which has come up in the recent times is data centers, where we house all our servers. And it is a big application nowadays with more and more emphasis on computers. And currently, as you know, under the lockdown period, a lot of things are happening online. So the demand for all these data centers is growing. Then there are other applications which are related to specific industries and chemical process industries, which I will not be discussing much in my presentation. Let me start with thermal comfort, which is the prime application of refrigeration and air conditioning. As we know, the basic definition which comes from the ISHRAE, which is the American Society for Heating, Refrigerating and Air Conditioning Engineers, is that HVAC provides condition for human thermal comfort. And what is that thermal comfort? How do we understand and appreciate it? It is based on the condition of mind that expresses satisfaction with the thermal environment. So the keywords to be noted is condition of mind, and the second keyword is satisfaction. And these studies are carried out through surveys, which gives an idea of the conditions under which most of the human beings feel comfortable. It has to be kept in mind there is no condition at which 100% of the occupants feel comfortable. And therefore, using the statistics, we try to maintain conditions where 80%, 90% or 95% of the people feel comfortable. So what affects comfort is mentioned again on the slide, which is related to human thermoregulatory response to any environment, and also the kind of work or activity in which human beings are involved when they are in that particular environment. So these factors play a very key role in perceiving the thermal comfort. So From a HVAC perspective, from the design perspective, the factors which influence comfort relate to the dry bulb temperature, the humidity which is being maintained in the environment, the velocity at which they are being circulated within the space, and also the mean radiant temperature based on the various surfaces which may be present within the conditioned space. Nowadays, people are talking of radiant cooling and heating systems, which primarily focus on this aspect also. Then there are other factors which affect the comfort of a person, which are more like personal variables. So one of them we mentioned earlier, which is activity, which is measured in terms of metabolism. MET is the unit. And then the clothing. And the units for clothing is CLO, which is more like the units of insulation. So a person who is wearing suit will not feel comfortable unless the temperatures are very, very low. And similarly, a person who is having very light clothing would require higher temperatures for comfort. And this plays a very important role in understanding that the comfort conditions depend on many, many factors and not just on dry bulb and humidity. There are other parameters which are important, which sometimes are not taken care of, due care of in the various analysis and studies. If we have shorter times of exposure, then we don't have very elaborate and details on what are the comfort conditions. So in metros, people are following conditions which are similar to buildings or office spaces, which to me does not seem a great idea. Then the time of the day or the year when you are providing that environment could also play an important role, because people adapt to those particular seasons by wearing their clothing, by food habits, and so many other things. Similarly, age and gender can play an important role. In many of these studies, this does not come out very clearly, but in some studies, it has been highlighted. And one more important thing is the mental state of the person. If he is not happy, if he is upset, then he doesn't feel the comfort, even though the conditions may be just right for him. So if the person is at peace, he has that calmness and the comfort comes out much easier in spite of little bit conditions not being as conducive. So adaptability is a very, very important aspect when we talk of comfort. So the past experience of the person and what environment does he prefer can play a huge role in thermal comfort. So nowadays in India and elsewhere also, people have adopted the adaptive models where you have a wide range of temperature variation rather than focusing on a very narrow range of 24, 25, 26 degrees Celsius. So the idea behind this is that the people adapt to surroundings by altering their clothing, posture, activity levels, what kind of ventilation they have. Even people can have flexible working hours, which can play an important role. So that is the emphasis in this particular model. And it has to be also noted that there are unconscious long-term changes which happen in the physiological set points when we try to adapt to a certain environment. So people who are used to cold environments don't feel that much cold as compared to others, because the body adapts to those environments which are naturally occurring in nature. So for refrigeration and air conditioning systems, the key technology drivers are mentioned on this particular slide. So the first important thing which is mentioned is how to ensure sustainable supply chains and how to ensure and capture sustainable materials in design and manufacturing of our systems. The second important aspect, which is again related to sustainability, is the need to go for renewable energy as far as possible. And more investment and focus is shifting to renewables because those could be more sustainable. And then whatever technology we use should be very efficient and it should consume as less energy as possible so that we can get the same benefit from that particular energy. The impact of any of the systems on the environment needs to be seen very clearly, and this idea is gaining more and more importance in the current times. Bioecology is a term which is picking up. It is ecology, but the emphasis is on the biological systems. And therefore, bioecology is very, very important and is the driver for all our current policies and future research. Human rights and safety again play very important roles, and technologies can affect these aspects, and therefore one should look at these aspects also when one is looking at the design of new systems. Let me talk a little bit about the supply chain and the energy which is embedded when we are mining the materials from the earth. So there is a term which is used which is called embodied energy, which is the energy required for mining of raw materials and their processing till you get the material at the location where it is required. So if you are constructing a building, when you get the material at the building, there is a lot of energy which is required. Then once you have the building ready, then there is a recurring cost or a recurring energy which is actually required for maintaining that particular building or whatever infrastructure has been created. Finally, at the end of the life of that particular building, you have to dispose of those materials in some way, or you have to reuse those materials. If we talk from sustainability perspective, then we should have a mechanism of either reuse or safe disposal of whatever trash is being generated. And embodied energy is a term which also includes all the energy systems, because for all our energy systems, we require materials as well as we require energy for their operation also. We have to have the complete life cycle understanding of all the energy systems which we are using, including renewables. Keeping the natural cycles in mind, we should try to capture whatever we are generating as waste and use it somewhere else in some way so that it does not remain on this planet forever. And that is an important consideration from a sustainable design perspective. So the hierarchy is we should reduce the waste and then we should try to reuse the materials as far as possible, or we can recycle the materials wherever possible or make compost so that it can be used as a feed to some other process. And then we should try to recover whatever is there in the waste which can be recovered, some metals maybe or some form of energy. And finally, whatever is left which we can't handle, that has to be disposed safely somewhere. But ultimately, we have to keep in mind that over a period of time, this should also become part of the natural cycle. If it will not happen, then over a period of time, whether it is 100 years or more, this landfill or waste will create problems for the future generations. Now coming to refrigerants and the aspects related to sustainability of refrigerants, the working substances which we use in our refrigeration systems. We are already aware of the ozone depletion potential, and we already know that the substances which had an ODP either have been phased out, like the CFCs, and the others are being phased out over a period of time, like the HCFCs. So that is already taken care of to some extent, although we are still continuing to use HCFCs in some applications, but the change is happening fast with more and more interest in the climate change. The second aspect is the global warming potential. This has picked up quite a bit in the last 2 decades, and emphasis has shifted to now GWP. So HFCs, which were conventionally thought to be very good, many of them have very high GWP, particularly refrigerants like HFC 134A. So this will also maybe getting phased out depending on the policy decisions which are happening and the discussions are happening internationally over various fora. The third one, which includes the emissions through the energy consumption. So even if we have taken a refrigerant which looks very good, but in terms of its energy consumption in the cycle or in a refrigeration system is very, very high, and it lands us into indirect emissions, which is the carbon dioxide equivalent emissions because of the use of energy over its life cycle. And then it is a problem, and therefore people are now talking of life cycle climate performance kind of tools to look into the aspects related to initial emissions or the direct emissions and the indirect emissions. Then the refrigerants need to be safe. We already know that there are some refrigerants which may be flammable, some of them could be toxic, or during the operation, the operating pressures may be too high, so it becomes a risk for the people who are operating the systems. All these considerations also have to be kept in mind when we are selecting a particular refrigerant for a system. So as you know, in the current scenario, the focus is on natural substances. So people think ammonia is very good because it is a natural substance. But the problem with ammonia, as we all know, is it is toxic. So although for cold stores and all, where the presence of human beings is limited and with proper safety precautions, it is still extensively being used. But one has to keep this in mind. Hydrocarbons are good again because they are again natural, but they are all flammable. So that becomes a safety hazard. Carbon dioxide has also been used in several systems. It may not be the best refrigerant in terms of energy efficiency of the system, but it is a natural substance. The other major issue with this is the operating pressures tend to be very, very high, especially in countries like India, where the ambients are very high. The operating pressures become too high. It could be approaching something like 80, 100 bars on the condenser side, and therefore safety becomes a concern. The synthetic refrigerants which the human race have developed are now being questioned. Especially I mentioned the HFCs, which have high global warming potential, and the new ones are HFOs, where the global warming potential is very, very low, but they also have mild flammability concern. And a new class has been created in the recent times, which is called A2L, to handle these mildly flammable refrigerants. Even people are proposing mixtures of several refrigerants, and many of them are mildly flammable. So there are no clear-cut solutions which are readily available for most applications. And one has to have a trade-off and decide what is possible in a given scenario. The second aspect from the sustainable perspective is to have systems which are based on low energy and not very highly energy intensive using electrical energy. So the first thing which we should look for whenever we think of low energy systems is to provide natural cooling. If the ambient is moderate, if the outside temperatures are suitable, humidity is suitable, then we can just bring in outside air into the space for catering to our cooling requirements. So ventilation air is used in such cases. So this is called a free cooling option because we are not investing much in this. Although there may be a small blower, etc., required to bring in free air if there is no wind outside in the environment. The second technology which has been extensively used in countries like India is evaporative cooling. Direct evaporative cooling has been used, desert coolers as we call them, for decades with very good success. The only concern which people are now raising about these systems is you need water for their operation. So water is also becoming a scarce quantity other than energy, and one has to look at the trade-off which is there. The other thing we have to keep in mind is evaporative cooling systems cannot be used in humid climates, and that is their limitation, and they cannot be used for removing the moisture from air if the latent loads are high in the conditioned space. There are other ways of saving energy, which includes heat recovery systems or enthalpy wheels, where we exchange the energy between outside air and return air to reduce the load on the refrigeration system or the air conditioning system. Then we can do some pre-treatment with the help of ambient air or ambient conditions, either through cooling tower or using the air directly. People have also used ground coupled systems because few meters under the ground, the temperatures could be much more moderate, and then one can get cooled water or hot water from the ground depending on the outside conditions, which can save on lot of energy for the HVAC systems. But the important thing we have to keep here in mind is when we are dumping heat into the ground or we are taking heat from the ground, we have to look at its impact on the water resources, if any, and also the geological aspects of that particular place. The next thing which people have tried is energy storage, and this is an interesting and a topic which has a lot of scope because with the growing interest in renewables, most of which are intermittent, how do we save energy for the period when that resource is not available? So energy storage becomes important. Energy storage could also be integrated with night cooling when the ambients are much lower so that the whole operation of the system becomes more efficient. So these are some of the ideas which are floating around for making the system more efficient. In the previous slide, we talked of the need for water, and both go hand in hand. We know that for generating energy, we require water, and if we need water, then we require energy. And some examples are mentioned on this particular slide. I will not go into the details of that because these are some common technologies which are being taught in all engineering curricula. So from refrigeration perspective, we know that systems which are water cooled are more efficient than systems which are air cooled, which means we should go for water cooling wherever possible, especially when the environment is dry. If the environment is humid, then we don't get much benefit in going for water cooled systems because the wet bulb temperature may be very close to the dry bulb temperature. But if the difference is substantial, then one should opt for water cooled systems wherever water is not an issue. But of course, we require treated water, and therefore availability of water is an important consideration whenever we want to go for these systems. So it is basically a trade-off between water and energy, which is not easy to appreciate and arrive at a conclusion. So one has to keep both these things in mind. There are some numbers which are there, how much energy is used for water pumping, treatment, etc. And then for the water, we again require energy so that we can withdraw the water from ground or supply it to wherever it is required. Nowadays, the trend is to harvest rainwater as much as possible and at local locations. And also, wherever possible, we should reclaim the grey water so that we get zero discharge either from the buildings, and many of the educational institutes are now going for zero discharge campuses. Let me take a case study of an energy efficiency system, which is based on a data center which we have installed at IIT Delhi. As you know, data center is one application which is providing or catering to the needs of the servers. So there is no human occupancy as such in a data center, other than the people who sit in the control rooms for operating the system. But within the server room, it is mainly the servers which are housed, which cater to all our computing needs as well as email needs and internet requirements. So in the data center which we have at IIT Delhi, we have a small thermal storage, which could be for up to about 10 minutes. And then in any data center, we need to have a high uptime. So there are various tiers which are there. For example, tier 4 will cater to 99.99% of the time, and only for a 0.005% of the time, it may not be available for several reasons. And as we know, sometimes the grid is not reliable, and therefore, for having high uptime, we have to either go for UPS for servers, precision air conditioners, and maybe back them up by DG sets in case the power outages are much more. So this is showing an example of the data center layout which we have in our campus at IIT Delhi. So we have these racks and we have the cold aisle, hot aisle concept. I will not be going too much into the details of all these, but you have a zone where you are having cold air and you have a zone where the heat is being rejected from the racks. Then you have precision air conditioners which are present within the server room. And in our design, we have provided a chiller, which is a water-cooled chiller, which is a big central system, which is catering to most of the loads which are there of the high-performance computing servers within the server room. The precision air conditioning unit is typically air-cooled because it has to operate all the time, even if there is a power failure. So the idea here is, in this particular design, we have gone for free cooling and pre-cooling, which means during the winter months, when the ambients are low, a server room would still require cooling because the servers are generating heat. So we are just capturing that heat and throwing it into the ambient. That is what is called free cooling. Similarly, when the ambients are lower, maybe we are not able to cater to all the cooling, but if we are able to reject some of the heat to the surroundings, then the load on the refrigeration air conditioning system will go down. These concepts are being taken into account in the design of our data center. And we are using water-cooled chillers. We are going for much higher chill water temperatures. As you can see, it is saying about 19 degrees Celsius, which is kind of unheard of. People typically talk of 712 degrees Celsius as the chill water temperatures for central systems. And then we have some thermal storage and chill water temperature difference is also kept high to minimize the circulation of water. This is a free cooling sketch which is shown here. In this particular sketch, if you look at it carefully, Then what is happening is we have a plate heat exchanger, which is PHEX mentioned on the slide. Then this PHEX exchanges the heat between the surroundings and the chilled water, which is circulated through the chiller. The chilled water is cooled using the cooling tower water whenever the ambient conditions are moderate. Whenever the cooling water temperatures are low, then the chilled water is directly cooled using the cooling water temperature. Whenever that scenario is not there, then it operates in the conventional mode, which is that the cooling water is cooling the condenser of the chiller and the evaporator of the chiller is cooling the chilled water. The RDHX, which is shown here, is a term which is used in data centers, which is a rear door heat exchanger. So this is a particular design which is there for the racks. So here we circulate the chilled water from the chiller and cool the servers or remove the heat from the servers. So now this slide gives a summary of the past data about 2-3 years back, where we collected the data for 1 full year to check which mode is in operation during which months in Delhi. So this data center is in Delhi. So we know that in Delhi, April to October is typically when we have hot weather. And after October, starting from November to about mid-March, the weather is really good. So if you see, the green bars show the free cooling mode. In December and January, most of the time, the system is operating in the free cooling mode. Then if the temperatures are a little bit higher, then we can move to the pre-cooling mode, which is kind of red dot in red bars, which are shown here. So you can see again, starting from October till April, we can have some pre-cooling, and therefore the mechanical requirement, the mechanical cooling requirement using the vapor compression system drops drastically. And only during May to September, or rather April to October, we are dependent more on the vapor compression systems and use a lot of electrical energy. So the term which is used is power usage effectiveness, which gives an idea of how much energy is being used for catering to a particular facility. And if we look at these numbers which are mentioned for this particular data center, the numbers look quite reasonable. So we are able to get an annualized value of less than 1.4, which is quite reasonable from the perspective of the environment such as Delhi. So with this example, now I come to the basic definition of sustainability, which has been well understood and well reported in the literature. And the most common one which has been reported is through the Brundtland Commission. And there was a lady from Norway after whom this definition is cited. So it is the development that meets the needs of the present without compromising the ability of future generations to meet their needs. So that has to be kept in mind. And there are some more terms which play an important role, which is you have to meet the basic needs of all. So there are issues of social equity which play an important role. And then you have to provide the essential needs first, which can always be questioned. And then there have been many other initiatives and definitions which have been proposed. So one more I have mentioned here, which is the Earth Charter Initiative, which is again talking of sustainability, but it does talk of nature, universal human rights, economic justice, and the culture of peace. It is not just related to technology, but there are several other aspects which play an important role when we talk of sustainability. So the three aspects of sustainability are the environmental quality, the economic prosperity, and the social justice. And this has been widely accepted now all over the world that from a sustainability perspective, you have to look at all these aspects in great detail. So you have the social aspects, which can also include the cultural aspects, which play an important role. So it includes the thought processes, our beliefs. They can also impact sustainability and the way we look at technology. And these needs to be seen in much greater detail. So I will not be going into the details of all these concepts because they will demand more time. One can look at these concepts and see what are the considerations in sustainability. Now, in our country, we have the Niti Aayog. So they are also looking at the sustainable goals. So we have the UN Sustainable Development Goals, which the UN has specified in 2015. And India is also moving towards that particular goal. And they have identified few sectors and they have some interventions which have been made and which are being made to promote sustainability. And one of the important sectors is buildings, which play an important role as far as refrigeration systems are concerned. So to summarize a bit about sustainability, sustainability is not just about energy, carbon emissions, or the impact of technology, but it is very, very comprehensive, as we have seen in the previous slides. And it is without borders or limits. And the true outcome will depend on the efforts from all the sectors, from all the people across the globe. And one country by itself cannot become sustainable. And this is also apparent during this pandemic when there is so much interdependency which is coming out in the current society. If we have to provide the basic needs of all, we have to provide the habitat for all. We have to have housing. Basically, we are talking of human beings at the moment. So there are schemes within the country where we are talking of housing. And we have to look at the habitat for all other beings also if we have to sustain ourselves. Otherwise, the human-animal kind of conflicts will continue to bother us for a long time. One more thing I want to highlight here, whenever we talk of buildings, it is not important that we should only have air-conditioned buildings. We can also think of evaporatively cooled buildings or naturally ventilated or mechanical ventilated buildings to cater to the various requirements in various climates. And this has been identified very clearly at the national level. And a lot of these things are being mentioned in the codes like EC, BC, etc., to handle the three types of buildings in a different manner. What is the role of technology? Technology can provide a significant role, but it will always remain partial because a lot of things cannot be decided by the technology. It should first be decided by the society, and then a suitable technology to cater to those needs should be selected. And we have to keep the health, comfort, and safety of all in mind whenever we are selecting a particular technology. It should not be for the selected few. So from a buildings perspective, we talk of lean, mean, green concept. So we should minimize the energy needs of the buildings through proper design, proper architecture. Then we should select and design systems which are energy efficient. And then whatever is the energy requirement, we should use as less energy as possible and use it through renewable energy sources. There are lots of renewable energy sources which could be used, but primarily there are two which are of current interest. One is solar and the other one is wind. Both of them are picking up well. And the others are depending on availability at that particular location. Some of them are easily available and some of them are not. Currently, the idea is to talk of net zero or net positive energy buildings so that the building is not dependent on grids for its own consumption. Rather, it should be providing energy to the grid so that the energy needs can be taken care of for all the sectors. Renewable energy is an important aspect of sustainable buildings, and we can spend few minutes talking about the renewable energy and how it is integrated into a cooling system. So we can have a solar photovoltaic system, or what is called as a building integrated photovoltaic, to generate energy, and this energy could be used for various purposes. The other option is to collect the solar energy in the form of heat, that is the solar thermal, and it can be used for operating cooling systems, or we can capture wind energy and directly convert it into mechanical or electrical energy. My main focus here is going to be on solar thermal. The solar thermal can be directly used for heating wherever there is a requirement. It could be used for generating hot water or for cooking or for some process applications, or it could even be used for cooling. So there are several technologies which are now there for generating cooling from heat. So the two routes are mentioned here. And as we know that solar thermal can be used for multiple applications, therefore all these things are mentioned on the slide. Typically in any solar conversion system, we would be interested in energy storage. Otherwise, we have to have grid in case the demand is continuous 24/7. So there are several cooling technologies which are there, which are driven by heat. These are called the desorption technologies. Again, I will not be spending too much time on each of these technologies. I will just show you few technologies on which we have worked in our lab at IIT Delhi. So any solar heating cooling system would have a solar collector, it would be storing heat, then it would be distributing heat, then you have to have a technology for producing cold, then you may like to store the cold and then distribute it to various applications. Now there are issues when we talk of solar energy. The issues are related to what kind of solar collector we are using, how much radiation is there, is the radiation more direct or is it more diffuse, what is the kind of maintenance, whether we would like to track the sun, and what will be the parasitic power for operating a solar system. All these factors have to be taken into account for designing an efficient system which is very cost effective. In our lab, we have worked on solar liquid desiccant cooling systems. The system looks a bit complex, but basically it has a dehumidifier which can remove moisture from the air using a liquid desiccant, and this liquid desiccant is regenerated using heat, which is basically the heat coming from the solar thermal collectors. And the air which gets dehumidified is subsequently cooled in a series of heat exchangers, indirect evaporative coolers, and direct evaporative coolers, depending on the configuration which has been selected by the user. Thermal storage is an integral part of the solar system, which could be in the form of storing hot water or concentrating the solution. Whenever we talk of solar cooling systems, there are a few issues which we have to keep in mind. The first one is the COP. Typically, the COP of the coefficient of performance of heat-driven systems is low. It could be 0.6, it could be 0.8, or even lower. And if these are the COP values, the collector area required for collecting the energy, the thermal energy, becomes quite large, which also adds to the cost of the overall system. And therefore, high values of COPs are definitely desirable so that we can reduce the cost. Then many of these systems, like the adsorption systems, can be either air-cooled or water-cooled. Again, the point is that we would require water in all these technologies. Then we have the parasitic power consumption, which is there in all these systems, which should be kept as low as possible, maybe typically less than 5 to 10%. Reliability is also important. So maybe you have to not only store, but also have a backup. And biomass could be a very good option as a backup for solar energy, particularly wherever the biomass is readily available in rural areas. So at one of the locations near Roorkee, we have an ongoing project where we are having a solar biomass hybrid based polygeneration system. So we are also providing cooling. We are also using it for cooking, and for heat is also being used for other applications. And we want to make it a polygeneration system. This is showing a picture of the solar dishes which has been installed. This is in a school in a rural area. And this shows the absorption chiller, which is heat driven. So it could be driven through biomass or solar thermal. So now I would like to summarize the presentation in a couple of slides. So from a sustainability perspective, the focus has to be the materials which we are using, the manufacturing processes which we are adopting. Are they sustainable? What working substances we are selecting? Can we go for natural substances like ammonia or air or water and avoid HFCs and HFOs altogether? Then we have to talk of using less and less of high grade energy and even minimize the energy required in the form of heat. We have to look at the source of energy, whether it is renewable or not. Is it coming in a decentralized manner? And we have to also focus on the end of life of the systems which we are using, whether we can make it as a kind of zero waste and align it with the natural cycles. It depends on us whether sustainability will remain a dream or if it can become a reality. We have to keep in mind that wherever possible, the technological option should be the option which should be taken much later. First option should always be non-technological. If we can avoid the use of technology and come up with solutions which are simple and straightforward, that is the best. But one has to keep in mind the solutions are not so simple in most cases. There may be ethical issues which may be involved in many solutions, and the trade-offs are complex. So one has to look at the complex trade-offs and then come to some solutions and then adopt appropriate technologies for those applications. We have to decide how much energy do we need and whether that kind of energy source is readily available on this planet or not from a sustainable perspective. We have to use materials, systems which are all eco-friendly. We have to align with the natural cycles, produce zero waste in some sense. The technologies have to be efficient, consuming the least energy. And wherever energy is required, it should be based on renewable sources. And it cannot be done at an individual level, even at the country level. It is all global. And therefore, there are lots of issues related to our social interactions, cultural interactions, harmony, peace, as was mentioned earlier in the slide. So with this, I would like to conclude my presentation and acknowledge my colleagues and co-workers with whom I have worked and gained a lot, with the funding agencies, my own institutes, IIT Delhi, which provided me the flexibility to work in areas of my interest. All the students who worked with me over the years and provided a lot of interesting output and conclusions, some of which I have presented in this presentation. I picked up a lot of things from the web, from the societies with which I have been involved, the research papers and the articles, and that has helped me to build my ideas. So thank you to all of you for your kind attention. And in case you have any questions, you can send it to the organizers and then I can respond to them. Thank you very much.
Thank you, sir. Thank you so much. Sir, the session is very informative and it is very, very useful to all faculty, also the scholars. Sir, there is a few questions from participation. So can you start the question and answer session?
Sure.
Yeah. Sir, one question is from Professor Priyanka Sawan. She's asking, can you explain the details about radiant cooling and its scope?
Okay, so radiant cooling is basically a technology where you have a radiant system which is installed in the conditioned space. So in this radiant panel, you will be circulating the chilled water. Now, in many cases, you don't even have an air circulation within the conditioned space. It depends on the size of the conditioned space, or you can have local circulation of air using fans, etc., or blowers to circulate the cooling which is being generated at the radiant panel within the space. The chilled water is coming directly to the radiant panel. There is no treatment of air which is being done outside. In case you need fresh air can be treated and it can be brought into the conditioned space. Otherwise, the chilled water comes, it is typically at a higher temperature as compared to the conventional systems which we use, and it caters to the cooling needs. It is expected that there will be no dehumidification within the conditioned space. Otherwise, there could be moisture which could be on the walls, etc., which is not a recommended thing. Therefore, in case there is moisture, then we have to bring in treated fresh air into that particular space. So these are the benefits as well as the disadvantages of this technology. I hope it answers the question.
Yes, sir. Yes, sir. Thank you, sir. One more question from Professor Pawar. Can you briefly explain desiccant assisted cooling system?
Okay, so maybe I can go to the slide in case you allow me.
Yes, sir. No.
So I hope the slide is visible.
Yes, sir. Yes, sir.
So as you can you see the mouse on the slide?
Yes, sir.
Okay, so if you see the air is coming into this particular duct here, so which is mentioned here as the air duct, and you have this component which is a dehumidifier. In this dehumidifier, you are circulating concentrated solution. And once the concentrated solution comes in contact with air releases its moisture to the solution. So the solution becomes weak because it has picked up moisture, and then it needs to be regenerated, which is shown in the lower part of this particular diagram. And after the dehumidifier, the air is going to a air water heat exchanger, which means because the air will get heated up during the process of dehumidification, because heat is released when the moisture is picked up by the desiccant. So that heat has to be removed in air water heat exchanger, which is shown here as the component C. And after pre-cooling of the air, it is passed through an indirect evaporative cooler where it is brought to the desired conditions. That is the basic cycle which is there, which is this particular case is the liquid desiccant cycle. It could even be a solid desiccant cycle. And the lower part of the figure shows that the desiccant which has become weak has to be regenerated in another component, which is a regenerator. So the one which is looking similar to the dehumidifier is the regenerator. So as you can see here, the solar collector is there on the right hand side, which is providing hot water to this particular component, which is the regenerator. And on this side, you have the tanks, which are being used for storing the concentrated solution, weak solution, etc. So this is very briefly what a liquid desiccant system would look like in actual practice. I hope that answers the question.
Yes, sir. Yes, sir. Now, sir, last one question. The question is from Professor Vikas Chaudhary. What are difference in adsorption cooling when use solar energy and waste heat energy?
No, if you are using either solar heat or waste heat, that does not affect the adsorption technology as such. So this heat has to be provided at certain temperature. There are systems which can operate at 80 degrees Celsius temperature. So if you can provide 80 degrees Celsius hot water from a solar system or from a waste heat, that is good enough for an adsorption chiller. So the source could be anything, but we just require hot water at a certain temperature. Some adsorption chillers may require higher temperatures. That depends on the temperature at which we need the cooling. And it also depends on the environment which is there, the ambient conditions, because that also affects the performance of the system. So is that the question? Does that answer the question?
Yes, sir.
So I'm asking, is that clear?
Yes, sir. Yes, sir. Sir, there is a few more questions, but I will pass on this question to you afterwards. Just once we get the answer from you, we'll send it back to the participation. So now
But I'm available. In case you have time, I'm available.
Okay. So the one more question, sir. Thank you, sir, for first of all to giving us the time. The question is from Professor Hitesh. How can expect better efficiency with renewable technology, especially in case of cooling?
So the major issue is whenever we are using a renewable energy source, the heat, for example, in a solar system, which is available is free of cost. In that sense, the operating cost should go down drastically unless we have very high parasitic power, which is a poor design of the system. But for a solar system, the initial cost or the capital cost would be much higher because you would require solar collectors to capture that heat. So that is what has to be kept in mind, and therefore there is a trade-off which is required whenever we are using renewable energy. If you have the renewable energy source which is readily available and there are several applications, then it becomes much easier to use renewable energy for the purpose of cooling. But if you're using renewable energy only for the purpose of cooling, then the capital cost has to be kept in mind. That is all I would like to say.
Okay. Thank you, sir. Thank you so much. So now I declare here the session. We can stop here. And on behalf of Department of Mechanical Engineering, Pimpri Chinchwad College of Engineering and Research, Pune, I am very much thankful to Professor Dr. Sanjeev Jain, sir, for giving us your valuable time and share your experience with our participation. Thank you so much, sir.
Thank you. Thank you to all of you, and thank you to the organizers for this opportunity. Thank you very much.
Thank you, sir.
Thank you. Bye.
Bye.
Every success has its own story. And in case of PCCOER, short for Pimpri Chinchwad College of Engineering and Research, the story began from its very inception in the year 2014. We are creating this success story under the aegis of Pimpri Chinchwad Education Trust, PCET, which was established by late Shri S.B. Patil in the year 1990. The trust has the vision to provide value-added education to the society in multiple dimensions, right from nursery up to doctoral program in all professional streams. PCET is a well-established and time-tested brand in education. PCET governs 9 institutes, which include a public school, a polytechnic, a management institute, an architecture college, a science and commerce college, and 4 engineering colleges.
Pimpri Chinchwad College of Engineering and Research is one of the leading colleges of Pune University. We follow the simple principle of 5-pillar philosophy. In this 5-pillar philosophy, the academic excellence is the first and the important pillar. The second one is research and innovation. Third is the training and development aspect. Fourth is the social awareness angle, and fifth is ethics and values. As a result of this, the students are developed in all dimensions, and the college is emerging very fast among the top colleges of Pune University as well as at the state level.
PCCOER has been founded by highly qualified and proficient academicians. We are located in the most refined cluster of innovative firms at the heart of an industrial hub. Here, our students have numerous career opportunities. PCCOER runs UG courses for civil engineering, computer engineering, electronics and communication engineering, and mechanical engineering. These courses have been approved by AICTE, DT, and Government of Maharashtra. The institute is affiliated to Savitribai Phule, Pune University. PCCOER is a place of excellence where your vision comes true. At PCCOER, you can wander through the ocean of knowledge and build the courage to seize your aspirations. We merge technology and participative learning to make your education more engaging, more gratifying. PCCOER has a skilled team of experienced, highly qualified, dedicated faculties and associates. They play their crucial role in fulfilling the vision of PCCOER. We have a systematic and standardized pattern for work execution and a perfect teamwork. We have a comfortable, pleasant, healthy and friendly campus where the students can exploit their true potential. We provide a self-sufficient and sustainable environment to develop the perception of how various concepts fit in collectively. Our approach has always been student-centric, and we stay attentive to their demands. The institute building is not just a structure of bricks and mortar, it's a temple for the learners. We provide the best teaching learning processes and a research-provoking ambience. We have well-equipped laboratories with state-of-the-art instruments that ensure that you are at the cutting edge of engineering and technology. Our infrastructure includes all the necessary suite of tools and software which help the students bloom.
We organize guest lectures of expert speakers from industry and reputed institutions like IITs for students as well as for faculties. We organize site visits, industrial visits in each and every subject for the students, so that students are exposed to the three-dimensional engineering realities. It is also mandatory for the students to undergo internship so as to gain invaluable hands-on experience. We have smart boards, we have screens, projectors, computers in each and every classroom. We have state-of-art laboratories where we encourage the student to perform experiments, to perform tests, to develop projects, to develop working models.
The institute campus is rich with greenery and blooming flowers, which lend a soothing touch to the demanding academic tasks. We have a huge ground where students enjoy outdoor sports and an open gymnasium for the fitness freaks. The indoor gymnasium has facilities for many indoor games. We have a vast library that houses more than 2,000 titles and 10,000 volumes of technical books, subscription to several technical journals, e-journals, and a large collection of literary books to cater every intellectual need. The reading hall has the ambience that motivates the students to stay focused and excel confidently. Empty stomach results in empty mind. Hence, we have excellent arrangements in the form of canteen and mess to satisfy the physical appetite of the students and staff. Other facilities on campus include covered parking, CCTVs, 24/7 security, and firefighting system. We have our own comfortably furnished hostel accommodation for boys and girls. Intellectual and psychological growth of the students is the centerpiece of PCCOER. Our students excel not only in academics but also in cultural and social events. We create various mind-feeding activities and conduct several exercises such as yoga workshop, mind education, wall magazine, self-awareness programs, inspirational programs, project-based learning, and annual gatherings. Our students participate and shine in co-curricular and extracurricular activities like Baha, Go-Kart, Robocon, Tiffin, Purushottam Karandak, Firodia Karandak, Daji Kaka Gadgil Karandak, and many more. Socio-economic empowerment of society is everyone's responsibility. PCCOER has always been a torch bearer in shouldering such responsibilities.
The students of our NSS unit regularly arrange blood donation camps. This year, our blood donation camp saw a response of about 150 blood donors. Our students regularly visit old age homes and orphanages, where they feel very happy and joyous to spend time with underprivileged elderlies and children. Students regularly take part in social activities like tree plantations regarding environment, as well as various cleanliness drives as part of the Swachh Bharat Abhiyan. Part of Unnat Bharat Abhiyan for rural development by the Government of India, our college has adopted 5 villages in Mawal Taluka of Pune district.
We are equipping our students with the set of skills, capabilities, and attitudes they need to succeed as employees, leaders, and entrepreneurs in modern world.
We are probably the only institute in India which has placed its 77% of students in first 2 batches. Around 400 plus companies give opportunity of placements to our students every year. We train our students right from second year, considering their improvement for soft skills, aptitude skills, technical skills. So recently we have conducted drive of Amazon, where the maximum package given was around 28 lakhs. 2 of our students got selected in Japan for the packages of around 20 lakhs and 17 lakhs.
I'm currently working in a Japanese company, tech firm, which is located in Tokyo, and I got a package of 17 lakh. When I was in second year, the Japanese training started in our college, and our HOD was very supportive, and she was like, you should do this training because it will be beneficial in your future.
Our central placement cell has placed more than 20,000 students. We have conducted 125 off-campus drives for 33,000 students from all over Maharashtra. Here, more than 1,400 students have secured their dream job. We have also channeled 150 online recruitment examinations. We are a vibrant alliance of educators and scholars who guide and motivate the students by setting an example, not by empty words. We at PCCOER emphasize on breakthrough engineering with breakthrough results.
माझा मुलगा शिवम भावसार हा याने डिप्लोमा केलेला आहे इन मेकॅनिकल इंजिनिअरिंग. तर त्याच्यासाठी आम्हाला डिग्रीसाठी खूप चांगलं कॉलेज आम्ही शोधत होतो. त्याचं सगळं व्यक्तिमत्व फुलेल, ऑलराऊंडर बनेल याच्यासाठी आम्ही बऱ्याच कॉलेजचा शोध घेतला. त्याच्यामध्ये नाशिकमध्ये आम्हाला असं कळालं की पिंपरी चिंचवड कॉलेज ऑफ इंजिनिअरिंग अँड रिसर्च हे कॉलेज खूप चांगलं आहे. आम्ही पुण्यातले 3-4 कॉलेजमध्ये गेलो, तिथे रिसर्च केला आणि त्याच्यानंतर निर्णय घेतला की आमच्या मुलासाठी हे कॉलेज योग्य आहे.
So I decided to get my admission in this particular college, that is Pimpri Chinchwad College of Engineering and Research, for my daughter Pallavi in civil engineering. She is doing really great in academics. Not only in academics, but there are various activities like curricular activities, co-curricular activities, extracurricular activities, and even mini projects. I am really satisfied that I took a very correct and very right decision by putting my daughter in this particular college.
No doubt our college is excelling in the placements part as well as the educational part, but today I would like to put forth one more perspective, that is the higher education. I would like to mention that I'll be pursuing my Masters of Science, MS in Computer Science from University of Southern California, Los Angeles next year. I would like to mention that all my teachers, my head of the department, our principal, our Dean III of Training and Placement Cell, everyone supported me and encouraged me. Definitely I will say that with the help of this college, I have personally developed a lot.
With the combined, sincere and focused efforts of management, staff and students, PCCOER has established a world record of filing highest number of copyrights by any organization in a single day, and this grand achievement was recognized and honored by World Records India and India Book of Records. Our faculties and students have published more than 280 research papers in international and national journals of highest standing in the current academic year. PCCOER has bagged many awards, amongst which are Innovative Leader National Award, IARDO Award for Academic Leadership, Special Award for Patents and Copyrights Filing, Global Education Excellence Award for the most result-oriented engineering college, and Outstanding Upcoming Engineering College in Maharashtra.
The research and development is a very important pillar for the progress of any institute. Not only filing of patents and copyrights, we have 8 products in a market. In order to strengthen the research and development according to the industry, we have more than 20 MOUs. All these MOUs are active MOUs. Under that, each department having an industrial visit, then internship for the students, guest lectures, workshops, seminars. So these seminars and all these activities try to bridge the gap between industry and academy.
Now all this is reflected in our university results. We have started just 5 years back, and in this very short span, we have achieved a position amongst top 5 best institutes in Pune University. Now, for an institute in its infancy, this is a great achievement.
We at PCCOER help the students to change the world for the better through their education. We create not only brilliant professionals but also responsible citizens. Our management, faculty, staff and students have a single motto: to become a national pride. It is the very secret of our rapid growth. There is a difference between dreaming and realizing dreams. Dreams require effortless sleep, and realization requires sleepless efforts. Everything is possible for those with a vision, a plan of action, and a determination to make it happen. Be a part of PCCOER to fulfill your dreams.